interference of light. Interference of light. So last class I have discussed about coherent sources. Okay, for interference of light, coherent sources are required. Now suppose these are two coherent sources, S1 and S2, as they are derived from the same source S. And suppose this is screen. Now what happened when light travels from the source S1 and S2? They superimpose. In this region, they superimpose. Now, light may superimpose in same phase, or they may superimpose in opposite phase. And if light superimpose in same phase, their intensity will be added. So resultant intensity will be what? Maximum. And if they superimpose in opposite phase, the intensity will be subtracted. So resultant intensity will be what? Minimum. So as a result of this, on the screen you will get alternate bright and dark bands. The maximum intensity corresponds to what? Bright, and minimum corresponds to what? Dark. That means you can say that there is a redistribution in the intensity of light. So this redistribution of intensity of light on the screen due to superposition of two light waves coming from two coherent sources is called what? Interference of light. Okay, so in detail I will explain through Young's double slit experiment. Okay, how you get bright and dark bands. So basically interference means what? Superposition of two light waves coming from two coherent sources, and it gives what? Redistribution of intensity of light. So you can say that the redistribution of intensity of light due to superposition of light waves coming from coherent sources. Coherent sources is called what? Interference. Okay. And it is based on the law of conservation of energy. Now you know there are two types of interference. We have seen that at some points on the screen the result intensity is maximum, that is due to constructive interference, and at some other points result intensity is minimum, and that due to what? Destructive interference. So you can say that it is of two types. One is what? Constructive interference. Constructive interference. Another is what? Destructive interference. Destructive interference. So constructive interference, where the resultant intensity is maximum, means the waves meet in same phase, and destructive means what? Where the resultant intensity is minimum, means here the waves meet in opposite phase. And the alternate bright all about your interference of light. Now, let me show you in details how we get the bright and dark bands. Okay, the bright and dark fringes on the screen. That is Young's double slit experiment. Young's double slit experiment. So suppose here, this suppose is source, point source S, and there are, this suppose was 3. Here we have 2 slits. So this is S1 and this is S2. So this is slit and this one screen. Now we know that here these two coherent sources are produced by what? Division of waveforms. Now you know light is a transverse wave. Here this is called what? Crest, and this is called what? Trough. So to represent the crest we use full lines, and to represent trough we use dotted lines. Because here light travels in the form of what? Waveform. We use the concept of waveform. So this corresponds to what? This crest, and this represents suppose trough. So here light travels in the form of wave, crest, trough. In terms of waveform, crest, trough. So here light travels from this source. This is suppose crest, and this one trough. Now here it divides, the waveform divides because there are not two sources, S1 and S2. So waveform divides. Now here crest, trough, now again crest. So this crest divides. Okay. Then trough. This one trough. Here also this is trough. This is a point on the screen. This is a point on the screen. Now you see crest, trough, again is crest. This crest is considered a point here. Then again trough, crest, trough, like that. Now here you see this is the center of the screen. Now here you see trough of both means crest of both means trough of both, crest of both, trough of both. That means what? Here the waves meet in same phase because crest of one follow the crest of other, trough of one follow the trough of other. So they meet in same phase. Here light meet in same phase like that. So this gives you maximum. So this is called central maximum. Now you see this point. Here you see crest of one, trough of other, crest of one, trough of other, crest of one, trough of other. So here they meet in opposite phase. They meet in opposite phase. They meet like this. Okay? They meet in opposite phase. So this gives you the fast dark. Similarly, you see here both crest, both trough, both crest, both trough like that. So here they meet in same phase. So it gives you fast bright. Similarly, here you see crest, trough, crest, trough, crest, trough like that. So here they meet in opposite phase like that. So it is your fast dark. And here you see both crest, both trough like that. So here they meet in same phase. So it is fast bright. So like that you will get other points also. So alternately you will get what? Bright, dark, like that. So this redistribution of intensity The dark are due to what? Waves meet in opposite phase, and bright due to what? Waves meet in same phase. So that's why we get alternate bright and dark fringes. So this is called what? Interference of light. Bright corresponds to what? Constructive interference, and dark is due to what? Destructive interference of light. Okay? Now we will find the condition of constructive and destructive interference. For that, we have to derive the expression for resultant intensity. Expression of resultant intensity after superposition of two light waves coming from two coherent sources. Now here I derive the expression for resultant intensity, because from that expression you can find the condition of what? Constructive and destructive interference. That means when you will get bright and dark fringes. Okay, so as we know, light wave transverse wave, so you can represent light waves by sinusoidal, means sine or cos waves. So let the displacement of two light waves, one you consider say y1 is equal to a sin omega t, and another you take say y2 equal to b sin omega t plus y. Let us consider these two. So here, where a and b are amplitude, amplitude means maximum displacement, and phi is the phase difference. Phi is the phase difference. And here, the phase of this wave is omega t, and for this omega t plus phi, so phi is what? Phase difference. So therefore, the resultant wave, what is the resultant wave? That is y is equal to y1 plus. We put the values y1 y2 is a sin omega t plus b sin omega t plus phi. So here you see this is the resultant wave. So for this function a is the amplitude, for this function b is the amplitude, and the phase difference between them is what? Phi. So now you can find the expression for resultant amplitude. Okay, you got this formula in oscillation chapters. Okay, if the amplitude of two waves are given and you know the phase difference between them, you can find the resultant amplitude. Okay, what is the result formula of resultant amplitude? So you can find the resultant amplitude. Okay, so here you see its amplitude is A, its amplitude is B, and phase difference is what? Phi. So therefore, the resultant amplitude will be what? A will be root over A square plus B square plus 2AB cos phi. So this is the resultant amplitude. This is the expression for resultant amplitude. Now if you know the resultant amplitude, you can find out the resultant intensity. So therefore, resultant intensity will be what? You know, intensity is equal to what? Square of amplitude. So it is A So amplitude may or may not be different. In fact, you know the amplitude of the two waves depends on the slit width. We are considering two slits, S1, S2. If their widths are equal, then equal amount of light passes through. That means intensity will be same and then amplitude also same. So if amplitudes are same, if you consider equal amplitude, then what will be the formula? I is equal to A square plus A square plus 2A into A cos phi. So in that case, it will be I is equal to what? 2A square plus 2A square cos phi. So it will be, you take 2A square common, 1 plus cos phi. So this is the formula, okay? So now we have two equations for intensity. One is A square plus B square plus 2AB cos phi. This is the case in amplitude are different. Another 2A square 1 plus cos phi. So this is the formula if amplitudes are equal. So in questions, if amplitudes are given equal or there is no information about amplitude, that means you consider they are equal. Use these equations. And if amplitudes are different, then use this formula. Okay, this is for different amplitude and this is for what? Equal amplitudes. So now we have the expression for what? Resultant amplitude. So you can easily find out the condition of constructive and destructive interference. Here you can note down one point. Firstly, you know, as I have given you that intensity is what? Directly proportional to amplitude. So you can write I1 by I2 is equal to what? A square by B square. And as I have told you that intensity of light passes through the slit depends on width. Is suppose a slit, its width is W. So the light passes through the slit proportional to what? Width. If width is more light can pass through. So you can say that intensity of light also proportional to what? Slit width. W is the slit width. So you can write I1 by I2 is equal to W1 by W2. So therefore you can write I1 by I2 equal to A square by B square equal to W1 by W2. This is one of the important formula you will remember. Okay. So here I1, I2 are the intensity of the two interfering beams. AB are the amplitude and W1, W2 are the slit. Okay. Now let me find out the condition of constructive and destructive interference. Condition of constructive interference. Constructive interference. So we know I is equal to what? A square plus B square plus 2AB cos phi. Now constructive interference means what? Where the resultant intensity become maximum. Now you see under what condition this will be maximum? You see for constructive interference, maximum. Is maximum. Now you see, I will be maximum if cos phi equal to what? 1. Because we know the maximum value of cos theta is what? 1. Therefore, cos phi is equal to 1. Now cos phi equal to 1 means what? What will be phi? The phi will be 0, 2 pi, 4 pi, like that. Or you can write phi is equal to 2n. So here n is equal to what? 0, 1, 2, 5. So here you can say that. So this is, you see, this is a condition of what? Constructive interference. You can say that for constructive interference, the phase difference between two waves should be what? Even multiple of pi. See, 0, 2 pi, 4 pi, like that. Even multiple. It is even multiple of what? Pi. So this point you have to remember. For constructive interference, the phase difference between two waves should be even multiple of pi. Okay. Now you can find the part difference. Now, part difference. So I have given you the formula between part difference and phase difference in wave chapter. Okay. Now use that formula. We know part difference is equal to what? Lambda by 2 pi into phase difference. Okay. This formula I have already given. So it will be what? Lambda by 2 pi. Here phi is what? Phi is 2n pi. It is 2n pi. So x will be what? It is n lambda. So this is also another important condition. So here n is equal to 0, 1, 2, like that. So you can say that for constructive interference, your part difference should be what? Integral multiple of lambda. It is 0, lambda, 2 lambda, 3 lambda, like that. Phase difference even multiple of pi. And part difference integral multiple of lambda. So you can say that for constructive interference, the part difference between two waves should be integral multiple of lambda. Okay, so this point you have to remember. Now let us find out condition of destructive interference. Condition of destructive interference. Okay. So we know that in destructive interference, the resultant intensity is what? Minimum. So for minimum intensity, so let me find out the condition. So we have I is equal to a square plus b square plus 2ab cos phi. So as we know, in destructive interference, the resultant intensity is minimum. So here you see, for minimum intensity, so you know, for under what condition this is minimum? If cos phi is minimum, and the minimum value of cos is what? -1. So cos phi is equal to -1. So what will be phi? It is pi, 3 pi, 5 pi, or phi is equal to 2n minus 1 pi. Okay. You may use 2n plus 1 also. Because both are odd multiple. So phi will be what? 2n minus 1 pi or 2n plus 1 pi. If you use 2n that case n will be 1, 2, 3 like that. And if you use 2n plus 1, your n will be 0, 1, 2 like that. So just you can remember this. If you are using this, n start from 1. If you are using this formula, then n starts from 0. So that's what you have to remember. So ultimately we can say that for destructive interference, the phase difference between two waves should be odd multiple of pi. Okay, so this you have to remember. Now similarly, let me find out the part difference for destructive interference. Now part difference x equal to lambda by 2 pi into phase difference. So lambda by 2 pi. So we use this one, okay? 2n minus 1 pi. So x will be what? 2n minus 1 lambda by. So this is the condition for destructive interference. So part difference is what? Odd multiple of lambda by 2. So here n is equal to what? N is equal to 1, 2, 3 like that. So you can say that for destructive interference, the part difference between two waves should be odd multiple of what? Lambda by. So these two conditions, remember that for destructive interference, your phase difference is what? Odd multiple of pi, and part difference is what? Odd multiple of what? Lambda by 2. So I have discussed about the conditions of constructive and destructive interference. Okay. Now let me give you one ratio of maximum to minimum intensity. After interference. So we have I is equal to a square plus b square plus 2ab cos phi. So here you see, therefore your I max, it will be what? A square plus b square plus 2ab for cos phi is equal to what? 1. Because the maximum value of cos is 1. So I max will be what? A plus b whole square. So this is the expression for what? Maximum intensity. Similarly, you can find out minimum intensity. And I minimum, which is s square plus b square minus 2ab for cos phi equal to minus 1. So I minimum, it is a minus b whole square. Okay. So we got the formula I max a plus b whole square, I minimum a minus b whole square. So therefore I max by I minimum, it will be a plus b whole square divided by a minus b whole square. So I max by minimum is what? A plus B whole square by A minus B whole square. So this is the ratio of intensity of light after interference. Because you know, after interference there are some points where the result intensity is maximum and some other points where result intensity is what? Minimum. And that ratio of maximum to minimum intensity. So this relation also important. You get questions from here. So today I have explained about interference, the constructive and destructive interference, their conditions, and of course the expression of resultant intensity. Now let me, before going to next part, let me give you one question. Suppose the width of one of the slit in Young's double slit experiment is 4 times the other. Find the ratio of maximum to minimum intensity after interference. Okay? The width of one of the slit in our double slit experiment is 4 times the other. Find the ratio of maximum to minimum intensity after interference. Okay, so here you see what is given. Width of one slit is 4 times the width of the is given. To find the ratio of maximum to minimum intensity, you have to know a value of A and B amplitudes. Okay. So we know I1 by I2 is equal to A square by B square equal to W1 by W2. This one I have already given. So here A square by B square, here it is 4W2 by W2 or 4 by 1. So from here you can write A by B is equal to 2 by 1. So therefore I max by I minimum will be what? A plus B whole square divided by A minus B whole square. So in place of A you can write 2. In place of B you can write 1. It is 1 by 1. So this way you can find the ratio of maximum to minimum intensity if we know the amplitudes. Okay. So, take another question. The phase difference between two waves at points A and B are 0 and pi by 2. Find the difference of intensity at these 2 points. Okay, the phase difference between two waves at points A and B are 0 and pi by 2. Find the difference of intensity at these 2 points. Now here you see, you have to find out the intensity. I is equal to 2A square 1 plus cos phi. equal amplitudes. Now here phi is given at point A it is 0, at point B it is pi by 2. So therefore intensity at point A it is 2a square 1 plus cos 0, it is 1 plus 1 2, it is 4a square. And at point B it will be what? 2a square 1 plus cos pi by 2. And cos pi by 2 is what? This is 0, it is 2a square. So therefore difference of intensities IA minus IB is equal to 4a square minus 2a square is equal to 2a square. So this way you can solve if you know the phase difference. Okay. So let me summarize today's class. So at the beginning I have discussed about interference. What is interference of light? That is a redistribution of intensity of light on a screen due to superposition of the light waves coming from two coherent sources. That is called interference of light. Then I have discussed about its types of interference, that is constructive and destructive interference. Destructive. In constructive interference, the two waves meet in same phase, so it gives you the maximum intensity. In destructive interference, two waves meet in opposite phase, so that gives you what? Minimum intensity. And because of this, you will get alternate bright and dark fringes on the screen. Then I have derived the expression for resultant intensity. Expression for resultant intensity. That is what? I is equal to a square plus b square plus 2ab cos phi and another 2a square 1 plus cos phi. So this is a formula when amplitudes are different, and this is a formula when amplitudes are equal. After that, I have given you the condition of constructive and destructive interference. For constructive interference, we have seen that phase difference is what? Even multiple of pi, and part difference is what? Integral multiple of lambda. This is for what? Constructive interference. Constructive interference. So here n is equal to 0, 1, 2, 11. Then I have given you the condition of what? Destructive interference. And what is that? That is phase difference is what? Odd multiple of pi, and part difference is what? Odd multiple of lambda by 2. So this is the condition for what? Destructive interference. Destructive interference. And now, at the end, I am giving you the ratio of maximum to minimum intensity. That is a plus b whole square by a minus b whole square. This is all about today's class. In the next class, I will discuss about the positions of bright and dark fringes. Okay. At what points on the screen bright fringe will form, and at what points the dark fringe will form. Okay.